Okay. Okay, folks, we're looking at a numerical reasoning, short test 10, Durham University, CEM, in preparation for the 11 plus. So this test has to be done in the allotted 15 minutes. It's a 15-minute test paper. Let's get started with question number 1. The following questions are based on the number sequence below. By how much does each term in sequence A increase to give the following term? Okay, let's have a yarn, please. Join us on this question.
So the following question 1, the following questions are based on the number sequences below. By how much does each term in sequence A increase to give the following term?
So what's they're asking for what the pattern is?
It goes and it increases it by 5.
Lovely. Next question, read.
How many triangular numbers are present in the terms given in sequence B?
Okay. There you go. There's sequence B. So what's the triangular number first of all?
A triangular number is...
We've done them before in the papers, so you shouldn't.
Those, you know those thingies, those dots, and then it goes like...
Triangular numbers is to do with patterns of triangles we have here. So we have 1, and the next triangle is made up of 3, and the next one is 6, and the next one is 10, and 15, and 21. Okay, so they're asking you in that particular one, which ones are the triangular numbers, which are the match? So how many the match?
3 and 6, 2 of them.
2 of them. Done. Question C. Next, read.
What is the next term in sequence B?
Okay. So question. So what's actually the pattern in the sequence B? You got to work at the pattern first.
It doubles each time.
Okay. So if it doubles each time, so we have to do 48 times by 2, which will give us what?
96.
96. Next, read the next part, D.
What is the range of the terms given in sequence B?
Okay, so the key word here is range. Now, so the sequence B is the one above us. Okay, so go on. What does the word range mean?
Range means when you get the highest number and take away the smallest.
Go on, then give me the numbers then.
48 and 3.
So the answer is?
45.
Done. Next.
What is the next term in sequence C?
So let's copy sequence C up, pop it over here. So what's happening here? What's the pattern?
It goes down by...
How does it go down? Are we minusing or anything else? So if it's going down, we're going to be minusing or something else.
Minusing.
Or squaring, or dividing, or square rooting, or cube rooting. Lots of different things that make the number small. So what is the number then? What's happening?
It's dividing
By
3.
Correct. So what's the next number then?
1.
Done. Okay, lovely. So Ayan, since you weren't able to do the test paper, I think I'm gonna get you to do all the paper today. Let's see what you can understand. Right, so far your question number 1, I'm quite impressed. You've done that quite well. Question number 2 is yours. Now look at the topic of question number 2. Does it look familiar?
No. Yeah.
You said no, and then you said yes. You gave me 2 answers. Is it familiar?
Yeah.
Okay,
Yeah.
when did you work on volumes?
Yeah, this week and last week.
Yeah, literally 2 days ago. So read, let's get cracking. Question number 2.
Question 2. The diagram below shows a through of water used by animals on a farm. The cross-sectional shaded area is 800 centimeters squared, and the length of the throw is x meter long. A. If the maximum capacity of the water through is 160,000 centimeters cubed, what is the value of x in centimeters?
Okay, the word that you're reading is what is called a trough. Trough is a type of structure that they use animals to drink water on. You see in a farmyard, horses or even pigs or animals drinking from this construction. So they told that the shaded area is 800. So the cross-section area is the area of the front. This bit that's shaded in. That's 800. Okay, the maximum water is that.
160,000.
Okay, so what do you know about the formula that you learned just literally 2 days ago? What do you tell me the formula?
So the formula is that
Volume equals
length times by width times by height.
okay, length times by width times by height. If you've got a cuboid, is your trough the shape of a cuboid?
No.
No, so don't give me that formula. That's a wrong formula. Length times by width times by height is only particular for a cuboid.
Base time by height.
Okay, now just let's go back to last lesson, which we done literally 48 hours ago. How do we start a volume of a prism question? Okay, let's have Musa. Can you help him, please?
You do.
All right. So for this, volume equals area times my length.
Stop there. That's exactly what I wanted. So, Mr. Ayan, have your brains been, reminded here? Yeah. Whenever we do a volume question, we do area time by length.
Yeah.
You don't sound very confident. Go. Okay. So what do we do now, Ayan? In this particular question, let me get rid of all the stuff that we just done without the camera being on. Let's get rid of that for the moment. And just whoops. Okay, let's put that back on. Okay, so we said volume equals the area times by the length. That is the master formula that we've been learning literally in the last 2 weeks. Now, so in this particular question, what is the cross-sectional area they're giving us? What's the cross-sectional area? Ayan, I can't hear you. What's the cross-sectional area, Ayan?
Yeah, 800.
And what is the volume of the trough?
Volume of the trough.
Volume of the trough.
160,000.
Okay, all right. Okay, so what do we got to work out now? The length. What is the length?
The length is x.
Exactly. So that's the bit we got to work out, the x. So how do we work it out? What do we do now with that equation? What were we doing in the lesson?
Now you do get the 160,000 and you
Okay, so you have 160,000 divided by 800. I'm just going to do up here a bit. I'm going to rub this off because I'm running out of space there. So we need to do now 160,000 divided by 800. That will give us the x. So cancel that down for me, please, quickly.
so you do cross out the 0 again.
We have left now 1,600 divided by 8. So if you divide that by 8 and divide that by 8, what's that leave you with?
2, 1.
That leaves you with
200 centimeters.
200 centimeters. Okay, right. Quick poll. Put your hands up next to your names if you manage to get that question right without working out. For the students in the class, put your hands up, please.
If one pig requires 5,000 centimeters cube of water per day, for how many pigs is there sufficient water in a full trough?
Okay, go on then. So what do we do now?
So you do 5,000
You do 160,000.
160,000 divide by 5,000.
Yeah. So you do 160,000 divided by 5,000, and the answer will be given us what for that. So we start cancelling. Come on. Cancel.
You can't-
1,
zeros
2, 3.
are
1, 2, 3. So you got 160 divided by 5 now. So how many pigs will that be enough for?
32.
32. Next question.
See, if one horse requires 40,000 centimeters cubed of water per day, for how many days is there enough water in a full trough?
Okay. So the same trough. So what number are we going to be using now?
160,000 divided by 40,000.
Okay, lovely. I like the way you said that so quickly and confidently. Now, what do we do with the numbers now? Cancel?
So, yeah, cancel.
How many zeros?
3.
4.
3.
Yeah, remember, because you got 4 on the top and 4 on the bottom, you get rid of all 4. 4 with 4, 3 with 3, 2 with 2, 1 with 1. Okay? In the previous question, we done 3 because we had never had another matching 0 on the bottom. But now we have 4 matching zeros, so we smash them all out. We left with now 16 divided by 4. What's 16 divided by 4?
4.
Done. Next question.
The farmer has 5 identical troughs to the one shown in the diagram above. What is the total volume of water he can fill up the troughs with?
Excellent. So what do we do?
160,000
160,000. Yes, go on. Keep on going.
Divide by 5.
Time by 5. Remember, it's got 5 of them. Each one is going to be that much, yes?
Oh, yeah.
So let's multiply it out.
0, 0, 0, 0, and 30. Yeah.
The answer is
800,000 centimeters cube.
so we got 8 with how many zeros? 1, 2, 3, 4, 5. Yeah, so it goes every single digit. Yeah, good.
If each trough costs 538 pound 75, what is the total cost of all 5 troughs? So
Go on,
you
go on.
do 538.75 times by 5.
Beautiful. That's it. Confidence, mate. You got to be, that's it. Multiply by 5. Good. So let's do it then. What's 5 times by 5?
25.
And 7 times by 5?
35.
Add 2, 37. 8 times by 5?
40.
Add 3 is 43. 3 times by 5?
15.
15 add 4 is?
19.
19. 5 times by 5?
25.
Add 1 is?
26.
Done. So it'll be how much pounds? 2,693 pounds and 75 pence. I want everybody to focus their eyes on all that working out that's done on that page. Okay, if you're not doing working out, you're not doing maths. This is not a mental arithmetic paper. This is a maths paper. Your working out is required. So when you're sending your homework to me by the electronic means, I want to see all of this lovely working out on your work for your homework goal. Excellent. Okay. Okay, Jan, you can have a little bit of break now. Let's have Eliza. Come in, please.
For 5 consecutive days, Jason bought 3 strawberry sweets and 2 orange sweets, whilst Brian bought 4 lemon sweets and 1 orange sweet. What is the total number of sweets Jason and Brian bought over the 5 days?
Okay, so question number 3A, how are you going to go about doing that then?
First you have to add up. All of the
Sweet.
amount of sweets. So it would be 3 plus 2 plus 4 plus 1, which is 10.
Excellent. And then how many days are you buying for?
You buy 5, and so the answer is 50.
Fantastic answer. Lovely. I like the confidence. Good. Next question, please.
What fraction of the overall sweets they bought are lemon flavored? So you you have to count how many lemon flavored sweets there are, which is 4. But because then you have to times that by 5, which is 20. So it'd be 20 over 50, and you can cancel that down by 10. So it's 2 over 5.
Beautiful. Next question. Go.
If the children collect the sweets they bought in a bag and chose one randomly, what is the likelihood of it being orange flavored? So you would have to do how many orange flavored sweets there are. So 2 plus 3,
Yeah.
has that which is 3.
You mean 2 plus, we got 2 orange sweets here and 1 orange sweet there. So we got 2 and 1 is 3, isn't it? Yeah?
Yeah. And then
Times it by 5 days.
15. So it'd be 15 over 50, and you can cancel that down by 5. So it'd be no, I meant you have to get it to 100. So basically it's 30%.
So you could do the equivalent method which you were about to do, or this is the traditional method when you change a fraction into percentage by timesing by 100 over 1. Okay, lovely. Next question, D, please.
What is the ratio of strawberry to lemon sweets purchased by the boys? So you have to count out how many strawberry sweets there are in total first, which is only 3. So and then you have to do how many lemon sweets there were, which is 4. Then because you have to times it by 5, so it'd be 15.
Oh, okay.
To 20, but then you can count that down by 5 again, which is just 3 over 4.
Yeah, so basically 3 over 4, if you can start with 3 over 4, we'll put 3 over 4 straight in the answer. You don't need to multiply it up and divide it by down again, it's done. Lovely. Okay. Yeah, that's good. And one more, last one.
If the children remove all of the lemon sweets, what is the probability of randomly selected sweets being strawberry flavored?
So we're going to take the lemon sweets out first. Well, how many lemon sweets were they?
There were 4 lemon sweets.
Time by the 5 days. So how many lemon sweets are they?
20.
So there's 20 lemon sweets, yes? If
Yeah.
remove all of the lemon sweets, we got 50 sweets minus the 20 lemons. That gives how many sweets left?
30 sweets.
Now they go, what's the probability of getting a strawberry now? How many strawberries are there?
There are 3.
There's 3 times 15, isn't there?
Yeah. So it'd be 15 over 30, and you can cancel it down by 15, so it'd be 1 over 2. Then you times it by 100 over 1, which is 50%.
So 15 over 30, yes? So
yeah.
We could just go straight into the percentage of technique. Divide that by 15, divide that by 15, divide that by 2, divide that by 2, and bang, question's done. Okay, thank you for that, Elisa, please. Okay, next question, question number 4. Right, question number 4, let's have Mr. Money.
The scale on the right shows 15 spheres of equal mass on a weighing scale. A, what is the total mass of the spheres on the scales in grams?
Okay, so question number 4. Okay, so if you look over here, what's the reading over here? How many kilograms is it?
9.
So 9 kilograms. Then when you convert that into grams, so how many grams is it?
900.
Are you sure it's 900? What do you time by?
5,000.
The answer is 9,000. You multiply by 1,000. In each kilogram, you have 1,000 grams. Okay, good. Next. Part B.
Does each sphere weigh?
So how do you break that out?
You divide it.
Fantastic. 9,000 divided by how many?
15.
15. So let's start cancelling down now. So let's have a look at 15. Let's have a look at 15 and 90. How many 15s fit into 90? 15, 30, 45, 60, 75, 96 of them, if you want to count it. So you're left with how many grams?
600.
We've got the 6 over here and the 2 zeros over here. 600 grams. Next.
What fraction of spheres are black?
Okay, so we've got 15 altogether. And the black ones are how many?
4.
So it's 4 out of?
15.
Can we cancel it down? And the answer is no, we can't cancel it down. There's nothing to cancel it down by. So don't share any common factors apart from 1, which is a bit of a useless one because dividing by 1 doesn't do anything. Next.
When a cube is added to the scale, the total mass increases to 9.8 kg. How much does the cube weigh?
So 9.8 is the new weight, 9 is the old one. So how much extra do we have?
800.
800. Well done, because 0.8 kilograms change it to grams, you times it by 1,000, gives you 800. So from there to there. Good. Next one.
What is the ratio of black to grey to white spheres?
That's the ratio of black to grey to white. So how many black ones are there again? There's 4 black ones, isn't there?
Yeah.
And how many grey ones are there?
6.
6. And how many white ones are there?
5.
5. Can we cancel that down any further, or should we leave the answer?
Leave that answer.
Because you can't cancel down any further. Okay, thank you for that, Mani. Mashallah, you done that question really well. You can, good. Right, we're on the last question now. Question number 5. I need Mr. Musa, please. Go.
All right, so first off, question 5. A. If Jude is 150 centimeters tall, approximately how many feet tall is he?
So first of all, in 1 foot, how many centimeters do we have?
I think it's 25.
You're close.
22.
Not in 1 foot. We have approximately. Let me put that a bit. It looks a bit rough.
30.
30.
Oh.
So approximately 30 centimeters. So you want to get to 150 centimeters. So how does 30 become 150, Musa?
You times it by 5.
What you do on the right, you do on the
Other side, and that would equal 1 feet times by 5 with 5 feet. So that should be the correct answer.
So that should be the answer over here. Good. Next.
B. If Ryan is 13/30 of Jude's height, how tall is Ryan?
So here's the key part. This fraction and the word off. So let's write it down. 13 over 30 off. What does off mean?
Of means something is apart or something?
No, the word off here means times. Mathematically, when you work in something fraction off something, the word off is translated directly into times.
Right.
And what's Jude's height?
Jude's height is 150 centimeters.
Okay, so look at my question. I'll set it all up now. It becomes a fraction question. So can you do any cancelling?
Yeah, 30 and 150. So first off, that becomes 1 and that becomes 5.
What do you divide them by?
You divide them by 30. Or
Yes, that's right. Good. Next, can we do anything else?
no.
So we multiply at the top. We multiply at the bottom.
That should give you 65 over 1. That is
Which is 65. Good. Next question.
If Jude's mother is 5'6" of Jude's height, how tall is she?
Oh, so she's 5'6". Jude's mother of Jude's height, so 5'6". Off, what's off mean again?
Of means times.
And what's Jude's height again?
Jude's height is 150 centimeters.
Can we do any more cancelling?
You can do cancel 150 and 6.
What should we divide them by?
We should divide them by 3. I mean 3. That's
How many 3 going to 150?
50.
50. So we left with now. Okay, can we do any more cancelling?
I don't know.
Yes.
Yes, I mean yes. 20.
Divide that by 2 and divide that by 2.
And that's 25 and 1.
So that leaves you with 5 times by 25 on the top and 1 times by 1 on the bottom. So what's the final answer?
125 centimeters.
Fantastic, young man, fantastic. Next.
D. The ratio of William's height to Jude's height is 6'5". How tall is William?
So William and Jude, William to Jude is 6 to 5. How tall is William? Let's have a look. Where's Jude gone? There. Okay.
150 centimeters.
So Jude is 150. So how does 150 become 5? What do you do to it?
We divide it by 30.
Or we could do the other way around. Let's get rid of the arrow. So 5 became 150 by timesing by
30.
And we do the same on the other side. That's what we learned in ratio. What we do to one side, we do to the other side.
And that should be 180 centimeters.
And done. Okay, next.
E. An equation to calculate Maria's height, M, in centimeters from Jude's height, J, in centimeters is shown below. Using this equation, how tall is Maria?
Okay, so we got 0.75J. What does 0.75J mean to you?
To me, it looks like Jude's height.
0.75 is the same as what?
Same as 3/4.
So you're going to work out 3/4 time by Jude's height. That's what that means. There's times there. Then you add 20. So where's Jude? Jude's 150, isn't it?
Yeah, it's 150 centimeters.
Give me a second while I get, okay, go on. So can we cancel that down?
I think you can.
Yeah, go on then.
Okay, so first you divide that by 4.
Will 4 go into 150?
No, I think it's 2.
We could do 2 first. I mean, 4, if you want to be safe, 4 divided by 2 is 2. 150 divided by 2 is?
75.
Okay. Now, so you got 3 times by 75 divided by 2, add 20. Let's copy that down on the side over here because I'm going to jump into the next page really. So 3 times by 75 divided by 2 and add the 20. What's 3 times by 75?
It's 225.
And what's 225 divided by 2?
225 divided by 2 is 112.5. And
What's 112.5? Add the 20?
132.5.
Fantastic. Okay. Now, I want everybody to look at the amount of physical, mathematical calculations that we've done there. How much maths was done. Changing the sentence into maths, cancelling it down, ratios, more cancelling, adding, multiplying, dividing, number patterns, cancelling again, and our beloved volume work that we just done recently. So if you look at the amount of work that's required on this paper, it's a lot of maths. A lot of maths has to be done. So I'm going to switch the video off now, and then I'm going to get your marks off video. I don't put your marks into the video. Okay, I don't want to embarrass anybody. So stop recording.